Okay, so we all love what AI can do, right? But here's the thing, it is getting incredibly thirsty for power. So how are we going to keep the lights on for our digital future? Well, the answer might just be hiding inside something that looks a lot like a shipping container. Yep, you heard that right. A nuclear reactor you can deliver on a flatbed truck. I know, it sounds like something straight out of science fiction, but it might just be the most practical answer to a very real problem. And to really understand the solution, we first have to grasp the sheer scale of that problem. So let's dive in. Because the digital world we all rely on, it has a huge, and I mean rapidly growing physical footprint. Think about it. Every time you ask a chatbot a question, stream a movie, or use a cloud service, you're tapping into these massive data centers. And these centers are just consuming energy at a rate that is simply staggering. And it's accelerating every single year. The growth is it's wild. What data centers needed just a few years ago is a fraction of today's demand. And the projection for 2030, wow, it's a nearly vertical climb. We are on a trajectory that our current power grid simply was not built for. So you might be thinking, why can't we just build more solar panels or wind turbines? And, renewables are fantastic, but they aren't always on. The sun doesn't always shine and the wind doesn't always blow. So what about traditional large-scale nuclear plants? Well, they produce immense power, for sure, but they can take decades to build and cost billions of dollars, making them way too slow to meet this urgent demand. So if the old solutions can't keep up, we need to think differently. We need to think smaller. And that brings us to the microreactor. Now this is a complete paradigm shift. Forget those massive, decades-long construction projects. The whole vision here is for something that's truck-sized, quick to deploy, and designed for mass production, almost like a car coming off an assembly line. And this isn't just some concept on a whiteboard. There's a real company, a startup named Terra Innovatum, and they are leading the charge, betting that these small-scale reactors are the absolute key to unlocking our energy future. And they are not alone in that bet. With around $230 million recently raised by just this one startup, it's pretty clear that serious investors see the potential. So this isn't just theory anymore. It's a high-stakes race to build our energy future. Okay, so how does a truck-sized nuclear reactor actually work? And, maybe more importantly, how is it safe? Well, at its core, it's the same fundamental science we've had for decades, nuclear fission. It's a proven, incredibly powerful way to generate heat, which then creates electricity. The innovation here isn't in rewriting the laws of physics, but in applying them on a completely new, miniaturized scale. And this is where it gets really clever. The safety design is fundamentally different. See, traditional reactors need active cooling systems, pumps that require power to prevent overheating. These new microreactors, though, they're designed with passive cooling. That just means they rely on natural physics, like convection, to stay safe. No outside power needed. The core is also completely sealed, making it a self-contained unit. And while AI's energy crisis might be what's kicking all this off, the potential applications for this kind of technology are absolutely huge. I mean, the potential goes way beyond data centers. Imagine a hospital that never has to worry about a blackout, or a remote island community freed from its dependence on expensive diesel fuel. These things could even be deployed in disaster zones, restoring power in days, not months. It's really about bringing stable, clean energy anywhere it's needed. But okay, as promising as all of this sounds, we have to be realistic. There is a long and very, very challenging road ahead for microreactors. The word nuclear itself is the first major hurdle, right? It raises a lot of public safety concerns that have to be addressed. Beyond that, there's a mountain of regulatory and political approvals to climb for each new design. And even if they get a green light, they have to prove this can scale affordably and that we have a solid plan for the nuclear waste. These are not small challenges. So this brings us to the ultimate question. Is this incredible technology the dawn of a new energy era? Or is it just another futuristic dream? The technology holds immense promise to solve one of the biggest challenges of our time, but its success depends not just on engineering, but on public trust and political will. And that leaves us with a final question to consider. Would you trust one of these in your neighborhood?